Um, well, number one, does the rotation actually change the
It
size of it?
is. It is not.
No. So it's this one is true. The next one, which is probably dilations, 3.4. If you look ahead in your book, I remember sometimes doing that as a student, looking ahead. Um, they do they would be false on that. So the rotation is it's kind of I agree with 3 and 5. 2 I agree with, but 4 I'm kind of questionable. I mean, I know it's
I
that.
think it would be rotated like on the point,
Yeah. Um,
which would be like
it's
the
if you rotated it, I think you might be able to do this one, but I'm not 100% sure if it could be done in such a way where you would get here. So we'll just go with it. Typically rotations move quadrants like yeah into kind of like that. Like you're going to see them, and it depends on the direction, whether you're going clockwise, CW, or counterclockwise. They typically move a quadrant. So just keep that in mind. And the the really difficult one, like number 6 here, well, I guess they're graphing it for you. Okay. So wow, this is really hard to do. These rotations are tough when they're not about the like origin. So when you look at number 6 here, they have graphed it for you.
yeah.
And so we got to put that point. I'm not sure why they're making you do it this way. 3, -2. So 3, -2 is about point B. So what you really have to do here, and I know this is going to be weird, is you really want to label the points in terms of like what they are from B. Like assume that B is your new origin. Okay. So think
Yeah.
of B as being 0, 0 right now. And C is 3, 2. A is -2, 5, like that. Is that clear how I came up with those from this?
Yeah.
Right now, if you look at that reference sheet I sent you, 180 degrees. So 180 degrees does not matter whether it's clockwise or counterclockwise. You might wonder why that is, but it gets you to the same place. The rule, the rule is here. This is clockwise, counterclockwise. The rule is that the XY pairs, they both negate.
Yes.
This, let me know if you need a moment.
Okay, I got it.
Everything good on your side, or do you need a moment?
All good.
Okay. So 0, 0 obviously would stay the same. This becomes -3, -2. Now the thing is though, is it's relative to B now. So like 2, -5 is from B. So it's 2 to the right and then down 5, 1, 2, right there. There's A prime. And then C prime is left 3 and then down 2. So there's C prime. Now, if the point that you were rotating about was not like right on one of the vertices, you would still do the same thing. You would call that your new origin and you calculate like the A, B, and C or D, and then you do the same sort of thing here.
Okay.
All right. So we got those 3 points. Now we can fill in the rest of the table, it looks like.
Yeah.
It's weird. What are they doing? What is going on? Um, so got this weird table. I mean, probably it'll make sense when we're all done. Really no. Okay, coordinate of A prime. I don't know why it's asking whether it will be the same or will not be the same. I'm not sure what it's referring
Is
to
it?
like as the
I think it
previous.
maybe it's like a check, like a you check the box thing.
Okay, so it's not the same as A. Um, B is the same, right? Because it's right there on it. Kind of like when we are doing those reflections and the point was on the mirror line. They
Yeah.
ended up being the same. All right. Measure of angle B. So there's angle B. I'm going to show it in red. And there's the other angle B. What kind of angles are those?
Uh, measure.
They're vertical angles. And what do
Oh
you know
yeah,
about vertical angles?
they are or they're next to each other and they're equal.
They're congruent. Yeah.
Yeah.
So it will be the same. All right. So the slope of A prime, D prime. So that's this one down here. How does its slope compare to AC?
It is the same. It is the congruent.
Okay. And then length of BC compared to B prime, C prime, I guess. Those also look to be the same.
Oh, that was
So the
strange.
idea, I guess, here, which I'm only sort of hypothesizing, is that your teacher wants you to see that the rotated image, the rotated triangle, the angles are the same and the sides are the same. This thing with the slope, only the slopes are the same only because of the 180.
Yeah.
If it were 90 degrees, it would not be the same. But that's only because of the 180-degree rotation. Thoughts on that? Questions?
No, it's pretty clear.
Um, the next bunch here, and we're gonna do them in sort of like pairs. We'll start with 7. You've got that 180-degree rotation reference in that sheet I sent you. I also copied it in. Those are the easiest to remember. Uh, what
All
is the
right.
rule for that? Can you find that on that sheet that I sent you? Or maybe got it in your
Side
notes.
negative x, negative y.
Yeah,
You just kind of
xy goes to
change.
negative x, negative y. You like get you there. So give me the new coordinates here. Give me the A prime, B prime, and C prime, please.
A prime is -4, -5.
Okay. A
Uh,
prime.
B prime is 3, -2,
Okay.
and C is 6, 1.
Okay. Now that whole thing I was mentioning about changing quadrants only applies when you're rotating about the origin. That's what this really means about the origin. They don't specify, but that's what they're saying. So 1, 2, 3, 4, 5. So go ahead and graph the original,
All right.
the -6. This is kind of a very thin triangle. Okay. And then the -4, 3, -2, 6, 1. 6, 1 is up here. All right.
All right, got it.
Okay, so the thing with 180 is it doesn't matter whether it's 180 or -180, clockwise, counterclockwise, it's always the same. It's always 180. So the one, which one on the rest of the sheet is going to be the same as this one that we just did? 8, 9, 10, 11, or 12.
10.
Yeah, so we're gonna do 10 next. So I would like you to do your best to not look at the screen and just graph graph the new ordered pairs, please. Oh, and I've not been doing a good job of labeling the graph. So if that's important for your instructor, and it probably is, please consider doing that.
Okay, so A prime is -3, -5. B prime is 1, -2, and C prime is 2, 3. Now I graph them. All right, got it.
Right. So now the next type of transformations that we're going to look at are the rotations that are variants of 90 degrees. So we'll start with number 8. Now your teacher isn't specifying this, but they're all clockwise. Like they should tell you that, and I don't know why they're not. But did your instructor mention those words, clockwise, counterclockwise, in class today? Or
Oh yeah, he just said to do it clockwise.
Yeah, but really you have to specify. It's like north, south, east, west. You have to sort of know which is which. So rotating 90 degrees clockwise, can you find that rule on the reference sheet I sent you?
Okay, let's see. Clockwise 90. Uh, negative y(x).
You're looking at counterclockwise 90. Go to the third one there where it says clockwise 90 degrees.
Oh right, y negative x.
Yeah, so what does that mean? It means that the whatever the y value is goes in the x position. Whatever the x value is, you negate it and put it in the y position. So give those a try here for L, M, and N. See if you can come up with that.
All right. Okay, so L prime is -3, -1. M prime is 6, 2. Yeah.
Okay.
Um, and N prime is -4, 3.
All right, so go ahead and graph it, and I think you'll see the transformation.
All right. All right, got it.
All right, so if you're a point here and we're going 90 degrees clockwise, you're going this direction. You can also get there by going this way minus 270, basically going backwards. Your teacher's doing a little bit different than that reference sheet I showed you. They're just using negatives instead of um, this, but you can see that if you go the other direction, 270, you get back to the same point. So which of the next, I guess, 9,
Yeah.
11, 12 are like that?
I accidentally have my volume very low.
Okay. Yeah, sometimes I'm not eager to always get, hopefully you said 12.
Yeah.
Okay. So why don't you, it's the same transformation. It's the xy becomes y minus x. And so you have to, the idea here is that you have to know how to get to the same point, which direction it is. And why don't you give me those new ordered pairs whenever you have them.
All right. R prime is -5, -2. S prime is 4, -3.
Good.
And T prime is 5, 2.
All right. Good job. Okay, so go ahead and sketch this, and I'll do the same after you've got it down.
All right. Got it.
All right. So you got all that down for this for these two?
Yep.
All right. So number 9, we'll go to number 9 next. So number 9 is a rotation of 270. And you'll keep you'll see me drawing like sort of this coordinate thing. So 270 is 90, 90, and another 90 gets you over here. But you can also get to it by going backwards 90. So this is 270 clockwise. Can you look on the reference sheet for the rule for 270 clockwise? CW is clockwise.
Uh, -yx.
Yes, negative yx. So xy, like you said, becomes negative y comma x. So the x goes to the y position, the y is negated. So give me those new ordered pairs, please, for this one, whenever you got them.
Okay, I have negative 2, 4.
No, your X value stays
Oh,
the same.
negative 2 and negative 4.
Good,
Um, 1 and negative 3.
good,
Negative 2 and 7.
very good. Okay, all right, go ahead and graph those and we'll take a look at the result.
Got it. I got it.
You got all that?
Yeah,
Okay, so the only one left you'll see is a minus 90. That's
that's
number 11. It's just like this one. So you almost have to create a table in your head that if it's a rotation, 180 minus 180, those are the same. 90 minus 270, 270 and minus 90. These are the ones that are the same. So number 11 is like the one we just did. All right, so give that a try. I'm happy to check your ordered pairs if you need me to. Did I write that down correctly? It's negative y-x. It's so easy to mess these up. Sorry for all the scrolling. Where I can.
L prime is 3, negative 2. M prime is just 0, negative 1.
Yep.
And N is 2, 0.
All right, good. Go ahead and graph those, please.
Got it.
Okay, do you want us to do we got some time left, or do you want us to do dilations, which would be the next thing, or do more rotations?
Uh, let's start on dilations.
Dilations, okay. All right. So let me find a couple here. Right. So we'll start out with some basics. So a dilation is a scale factor, and there's a pretty simple rule is if k is greater than 1, it's an enlargement. If k is less than 1, it's a reduction. And you might wonder, what if it equals 1? Well, that's no change. Okay, so tell me what you see here. Is for each of these, is it an enlargement or a reduction?
Number one is enlargement. Two is reduction. Three is enlargement, and four is reduction.
Very good. Okay, so now the next type of problem that you might be given is where you get, and we'll just do a segment here so you can maybe draw. Do you have any graph paper today?
I do not.
Okay. So let's say k equals 1/2. What that means is that you take each of the x and y values and you multiply it by the k. So your a prime becomes 1 comma 2. You're cutting in half. B prime, you're similarly cutting in half, 3 comma 1. Is that okay?
Yeah.
All right. So what I'd like you to do here is try to roughly sketch out A, B, and A prime, B prime. Now, I know you don't have any grid paper, but just kind of rough sketch it. So I want you to see what it actually looks like when you scale it.
Got it.
Right. So I grabbed this problem from a worksheet here where it did have the graph, which makes it substantially easier to graph the new points here. So 1, 2 is here, 3, 1 is there. What do you notice about the length? So A, B, A prime, B prime. What do you notice about the length of A prime, B prime?
The length is cut in half.
Yeah, it's half. It's kind of interesting. So these aren't equal, sorry. That's the thing there. All right. So here is another type of problem you'll see where they give you a graph and they give you a k value. And what I would recommend doing here is making a little table. Your original points, -1, 1, 1, 1, minus 1, 0, and then figuring out your transformed points. So you multiply that k value by your x and your y each time.
Right. Was a prime negative 3, 3,
Yes.
and b prime is 3, 3, negative 3, 0.
All right. Go ahead and, if you can, make a sketch either of this original and then the enlarged one. Kind of be cool to see what happens.
It becomes larger.
Yeah, you should see it get quite a bit larger. In fact, and we'll do this real quick here. 3, 3, 3, 1, 2, 3, and then minus 3, 0 here. You'll do this later in the course, but we can do it now. The area of the original triangle is 1/2 base times height. The base is this flat side here, or this one, the two legs. That's 2 times 1, which ends up being 1. The area of the other triangle is 1/2. Now its base is 6, its height is 3, which ends up being 9. So you'll learn this later in the course, but the scale factor tells you something about the area. It's k squared to get the new area. All right, so let's do some lighter problems to close out here. So here are the instructions. It says determine whether the dilation from A to B. So you have to know which one you're starting with and which one you're ending with or stopping. It's really important that you figure out which is the start, which is the stop, because it's easy to misinterpret that. So is from A to B a reduction or an enlargement?
Reduction.
Reduction. Now, to find the actual scale factor, you need to find corresponding vertices. So like you might use these 2 points. Doesn't really matter which ones, but they have to correspond to each other, the ones in blue, or maybe it's the ones in green. But I want you to write those 2 points and see if you can figure out the reduction amount.
Uh, 1/3.
Okay, which point did you use? Points, the red, the blue, or the green?
The green.
Okay, so the green is 1, -1. That's the B. Put that in the wrong spot. And then 3, -3. So you have to recognize that you're dividing by 3, but we say multiply by 1/3 in this part of the course. All right, let's have you try one more to close out here. Actually, we're running out of time, so I'll just quickly run through it. Okay, so from A to B, you can see that it gets larger. And if I pick, these 2 points, it's 0, 2 goes to 0, 5. Well, how do you go from 2 to 5? Well, it's really like an equation. It's 2k equals 5, divide by 2, divide by 2, so k equals 5 halves. And you might wonder, well, does that work for the previous one if you write an equation? Yeah, it does. 3k equals 1. I'm using the first point. Divide by 3, divide by 3. That's how you get your value of k. All right, we do have to stop there for today.